Is it on? Okay, great. Okay, so hi everyone, and thanks so much for coming. I know it's the end of the day and everyone's a bit tired, but there's something that I want to talk about which is very different to some of the things you've heard today, and hopefully it's fun and it's different and it will make you think. This presentation is unapologetically very idealistic. We're talking about things today that they don't exist today, they may not exist for many years. So if you're the sort of person that says things like this to yourself very often, then congratulations, you're a realist. You actually help build all of these sorts of things, but this presentation is probably not for you. There is no project at the moment, there's no code, and there's definitely no ICO. What there is a series of random ideas that have occurred to me over the years when I've been a computer programmer, and basically things that I think we could do better. And this is like, think of it like a collection of random short stories of ideas that I think will help us move beyond apps and code, basically where we are and into the future. My goals of this presentation are very simple. I just want people to think, and if anyone's on the same wavelength when they're either in the audience today or they're reading this or watching it later on, please drop me a line and get in touch. I want to meet people who are thinking along these lines. So let's start off with saying what's wrong with computing today. Very little, actually. In fact, I think we should start by saying that computing today is pretty good. The apps, the phones that we have, pretty much everyone has a phone, and the apps are super powerful, and they let us do so much. But of course, things can always be better. And I did happen to see this series of tweets recently from Dean Eigenman, who says, I think, spot on that there's lots of problems with Dapps at the moment, not just around scalability and fees and so on, but also around the UX as well. And I think we could do so much better than what we've got at the moment. But how do we get there? Well, part of that is to recognize that the reason we're in this situation at the moment is because what we've done is we've taken the traditional way of making apps, which is all these technologies on the top, and all these concerns that we have to address as programmers in the back end, and all we've done is we've swapped out cloud storage and we've replaced it with on-chain storage or IPFS or Swarm. But we still have all of these problems, and we haven't solved any of them yet. So we're all in this room today, and we're all at this conference because we believe in decentralization. But it is my firm belief that if we're really going to make people use the stuff that we're building, we have to offer them a much better experience than we're doing now. And it can't just be a little bit better. It has to be vastly better for people to care. So after thinking about this problem for some time and advising companies, particularly talking to people like Jared from Status, who's actually working on building these new platforms, I started realizing that the only way forward for us, I believe, is to build a brand new computing platform. We can't just keep piling stuff on top of the things that work in the past and never worked in the past at all, actually. So this is a very quick taster of what I think some of those ideas behind this new computing platform should be, and how we should take some of these ideas and sort of work together as over time, over the coming years, to try and build a radically different platform. Let's start at the beginning. Everybody builds apps and dApps, but very few of us actually take time to consider what they are. And it's very interesting when you think about what one is, because you realize that what they are really are translation layers between the human and the machine. In fact, if we could put a Wi-Fi chip inside our brains, we wouldn't need an app at all, because we would just be able to connect from using our Wi-Fi chip onto an AWS server or to the Ethereum cloud, and we'd be able to read and write directly off there some sort of binary or JSON data. And instead, we don't have that. Instead, we have to build these user interfaces. They are the thing that sit between the binary code and the sort of human being that's actually interpreting this. There's also one more thing to say. The way that design is all about how we highlight data, and you can see that the Bitcoin balance here is actually much bigger than, for example, the previous transactions. And a good designer will consider the emotions of the person who's actually going to be looking at these interfaces, especially when sending money is concerned. So that's something else that you wouldn't be able to get with just a Wi-Fi chip in your brain. But really, apps today, they do so much more than just these user interfaces. And if you think about what's behind an app, we also have these two layers. We have a collection of services and data that's actually written and read by these services. And today's apps tend to be one company like Airbnb that do the whole thing. They offer the interface and the services, and they store the data for you. But the real problem is that we don't know where that data is being stored or what actually is being processed on our phone versus what's being processed on the cloud. So I don't know if any of you know here, for example, that if you have iOS, then the little memories that they put together, that Apple puts together for you, are actually processed on your phone as you sleep. So they don't actually go anywhere. All the image recognition is done on the device. Whereas if you have an Android phone, that's all done on the cloud. But right now, it's impossible to know the difference. So we can't talk about services today because there won't be enough time, but we are going to talk about data. And getting all these two layers correct starts by getting data correct. So the very first thing we need to consider is data ownership. Now, data ownership goes way beyond who owns my photos and comments. And I think the debate at the moment is centered around this, and that's just not good enough. Because what we don't realize is that the real value in our data is our relationships. And I ask people, if you went to a bar and you sat down on one of these stools and you met somebody here and you started talking, it would be absolutely absurd for the bar to turn around and say, hey, I own that relationship. But that's exactly what happens today when you start talking to people inside Facebook or Instagram or Snapchat. So these reputations and these relationships are currently existing in islands, and all these islands are not talking to each other at the moment. So I think the first thing we need to get right in this new platform is to bring a community of friends and our reputation to the apps that we use. And luckily, and only sort of quite recently, Tim Berners-Lee has started a project called Solid that aims to do exactly this. And I think this is the right way round to think about apps. You own the data, you have what's called a solid pod, you put all your data into this thing, and then you take the data to the apps. So the apps become the interface to the data, and everyone is still free to compete on how they show the data, but it's still your data. So this is a big step in the right direction. But then we must also consider privacy as well. And it's quite mad at the moment to think about things when you consider that an iMessage or a Facebook message or WhatsApp message is essentially going back to servers which are controlled by developers. And this is the way that computing has bizarrely grown. Even if I want to message someone in this room, it does not go from my phone to somebody 10 meters away. It goes to many, many servers, often owned by Apple or Amazon or so on. And so we've got to get this bit right fundamentally at the operating system layer. And luckily, again, there's always hope on the horizon. Even though developers should never see private messages or content, there are companies now that are working towards solutions to this. And the best one at the moment is Status, which runs a Ethereum client on your device and uses a Whisper network to send the messages. So that this is the first messenger that I know of that the messages aren't going back to the developers who make the apps. Now, Status are also working on something very interesting around all of this, because something called extensions that allow you to take out the most sort of things like group chat or video streaming, things that are very common patterns that developers have to do. Take those out of your app and use a decentralized private alternative instead, using Whisper and using Swarm and so on. So really, keep an eye on this. People are starting to use extensions now, I hear from Julian, but I think Julian and Jared are doing a great job at this. What we need, of course, is to not just handle this stuff at the app layer. The app layer is not good enough. What we really need to do to get privacy right is we need to go deeper down and start looking at the operating system as well. Now, mobile computing today is way more secure than desktop computing. And one of the reasons is because mobile apps are all sandboxed by default. So if you want to do anything with Bitcoin or Ethereum, you're much better on an iPad or on a phone than you are on a desktop computer. But there's one thing that isn't sandboxed, and the most important thing of all is the network access. Because right now, we have this crazy sort of free-for-all situation where any app can do anything it wants. So the privacy model is kind of inverted. What we really want to do is we want to control the data that leaves our devices. But instead, what we have is this sort of confusing screen that we have to deal with. We download an app. We've never seen it before. Some friend of us told us, that it's a good idea. We don't know the developers. We've never met them personally. But within the first 5 seconds, it's asking for access to my camera. And the real problem here is that we don't care what has access to our sensors. We only care when that data leaves our device. But we don't have the networking layer and the understanding of the data at the moment to actually intercept the data before it goes off onto the internet. So this is something we fundamentally have to fix. So we're not going to really make any progress with privacy until we start acknowledging that this has to be handled at a different layer than we're handling it at the moment. We can do some things to make life a little bit safer and easier. We can install things like Little Snitch, which will catch outgoing connections and allow us to approve them on a case-by-case basis. But this gets very tedious very quickly, so most people don't use it. There is some hope on the horizon here as well. There's a project called Elastos, which maybe some of you have heard of. It's a Chinese project that starts with a very, very wise decision, I think, which is that all apps do not have direct access onto the internet, and instead they have to make some decisions using some rules as to what they are allowed to contact, and all the messages are going through like what they call the Elastos carrier system, which is a way of safely relaying messages in a peer-to-peer way. And remember, of course, what the problem we've got with outbound connections is not peer-to-peer connections that, between me and my friend, but connections that go back to centralized services. So I think what we really need to do is consider some sort of privacy guardian that sits between the app layer and the operating system, something that is in charge of letting out data only when it should be, under our sort of control, our permissions, and some sort of tracing system as well, so that I can take a photo on my phone and I can go to some settings page somewhere and I can see that it's being cryptographically signed by the camera, and I can then follow the path of where it's been sent, so I know if it's ever left my device. So even if we had that, though, there's still another problem. Today's operating systems are doing a great job at providing stable computing and scheduling tasks on the kernel and so on. But what they're not doing is understanding the actual data that's flowing through them. There's no comprehension of what a piece of data is. It's just sort of zeros and ones to them, even though that 0 and 1 could well be a picture of ours that we've taken, something personal. So what I think we really need to do is we need to try and build a platform from the ground up that has a comprehension and understanding of the data that we're actually using, because this data is our private thoughts and memories. This is an extension of our brain. So that leads me to this other idea, which I'm sort of thinking of in terms of data types. I don't really know what to call this, but if you think something like Haskell, it's got this idea of type systems, and but I think I'd like to take this idea and develop it a lot further, to add things like field validation, regular expressions, and so on. And the whole reason that this idea came about is because I've done plenty of work in the past at startups, and I've also had the privilege of working in some very big corporations where most developers spend most of their time not doing any real programming, but actually doing what I call data mapping. Just simply mapping data from one SQL database to one Redis to one JSON thing, and then all the way back on the client. And every time that you are doing some mapping, you're constantly having to rename some of the fields. You're constantly having to check the field length. You're having to make sure that, you have to do validation on the server as well as the client, because you never know what's being posted on the client. Most programming these days is this very boring, basic plumbing of one system trying to talk to another. And I think this is where we go wrong. We spend so much time thinking and believing this myth that, oh no, every use case is different and we have to design everything from scratch every time. We have to reinvent the wheel every time. And of course, it's not the case at all. If you had an e-commerce website that uses Stripe, and let's say something goes wrong with Stripe and you then have to use Braintree, well, they're still dealing with payments and they're still dealing with credit cards. But right now, the data format for Stripe and Braintree is entirely different. So you have to then, as a programmer, build some sort of dumb abstract class on top of it that does the translation. And this just takes up so much time. And I just think the world would move forward so much faster if we could start agreeing on ways to standardize data. So one approach is to standardize. And by that, I mean, we just come to some sort of agreement as a community of people about what, for example, a credit card should look like. What fields should it have? How should we validate it? I guess what I'm looking for is some sort of composable type system. It has to be composable. It has to be expressive enough to explain the links between data as well. But where would we store this sort of thing? Let's just say we could invent one. Where do we store the types? Here, I think we've got a big breakthrough, because we would not have been able to do this, I think, prior to 2014. This whole idea would never have got anywhere. And the reason is that if, let's say, Amazon came up with this idea, they would store it on the Amazon cloud, and Google would turn around and say, sorry, we're competitors, we're not going to do this project, it's a silly idea. But now, for the first time, we have a really neutral, immutable place to put these definitions. We have a way of actually storing how we think data should be structured and how we think data should link together. And I think there's some good promise here, because we've seen already that a community of people can come behind an idea and say, there's no point in having multiple token standards. Let's just figure out which one we want to go with. There's another thing that I was told about last month at ETH Berlin, which I think is also very promising too, which is not so much a way of standardizing, but a way of doing on-the-fly conversion between different types of data. And this is a project by Vlad, who's sitting in the audience here, called Framework. And the ideas behind Framework is so that you don't have to go in advance and try and do all your standardization. You can build converters between different standards that exist already. So for example, there's various different projects that have open bounty standards at the moment, like status open bounty and so on. But they all use slightly different field names and slightly different data types. So it's possible to use Framework to actually go from one to the other on the fly. Although I've still got to look into this in depth, Vlad has also told me and Framework is doing a lot more than just that as well. So definitely do check out the URL here at the bottom. Okay, so once we've got types, we also get relationships. Relationships will allow us to say things like a person has an address, has a zip code, and a zip code can then be translated into an XY coordinate. And if we can start organizing our data so that no matter what app it is that makes that data, it's all in the same sort of standard, and there's links between it, either by explicitly defining the links or letting some sort of machine learning algorithm work out how we usually normally use the data together and how it could possibly be related, then we get rid of this awful sort of plumbing programming that we have to do, this CRUD programming, where instead of having to define all the fields on a form and then write all the error checking in and make sure that we've got red highlighting here if it goes back to the server and all the rest of it, instead what we can do is we can throw these data types onto the screen, and the screen will be able to, on the fly, render a form that's perfect for our needs at the time. And this, I think, will eliminate so many bugs and make the whole process of programming so much more pleasurable for everyone. part of my talk is called Beyond Code, and when I talk about how I think we need to go beyond code as a community of computing people, everyone tells me about the same thing, which is visual programming. And they all say, have you heard of Snap? And of course, you know, this I think is fantastic, because this is all the fun and promise of programming that we teach children. You know, programming can be fun, it can be friendly, it can look beautiful, you can make cool things with it, and then of course we have to break the bad news to them that if you actually want to get anything done, you're going to be spending all of your life in front of a computer that looks like this. And the whole reason is because as much as we try to make visual programming work, and so many people have tried to make this thing work, all we ever do is end up with a big mess like this. And the more complicated your program is, the more mess you get. So I don't think visual programming works for programming per se, but there's one thing that definitely should be visual, and that is when you're building something visual, you should describe it in a visual way. Unfortunately, we've got this instead. Somehow, in the year 2018, the most sort of advanced way of making a button on the screen is to write XML that is sort of pre-parsed to about 5 or 6 different NPM modules to output something which we should have been able to drag and drop onto the screen in the first place. You know, this is absolute madness to me. And yet this is what classes itself as sort of leading edge programming at the moment. So the root cause of all this is actually that we've not really left imperative programming. We came up with it in the 50s, and we've never really come up with anything better since. So imperative programming, of course, for those of you who don't know, means that you have to go and tell the computer every little thing to do, and you have to anticipate every problem along the way. You have to think about every conditional code path that could go in and all the errors that could be encountered then. And of course, you know, this is an impossible thing for anyone to do. Even the best programmers simply cannot anticipate all the different paths that it will go down. And therefore, we end up with bugs. And what do we do when we get bugs? We have to write unit tests, which are more programs to check the programs that we built before. And I just don't think we're going to get anywhere, really, if we keep this model for the next few decades. I think we're always going to be stuck with buggy computer programs that take too long to build. And I think the only logical way forward, and the way that we have to be starting to think, is that we need to get the computers to write the computer programs for us. We need some sort of way of communicating not what we want it to do, but the end result, either by goal or by what I'm sort of inferring as intention. Because if we can communicate our intention to computers, and for the first time they know where the data sits, how the data relates to other data, then I think it will be able to go off and get the data that we're interested and give us the answer that we want. And it can do so in a way where it's using all the decentralized services along the way. So to sort of finalize this thought, I think UIs in the future will be personalized. They won't show you form fields that they don't need to show you, because it will know how to answer that question. They'll be disposable. There'll be things that are generated to serve a unique query at the right time, a bit like Google Assistant or Siri is, but imagine that times 1,000. And they'll be generated on the fly. The idea of having to manually and with XML map out every box is madness, and that needs to go away. And all of this, if it's built correctly, will be talking to decentralized data and decentralized services rather than some sort of big corporate cloud database. And my final thoughts on this, to sort of go out and zoom out a bit more broadly, is that I think the world is full of creative people, and they always surprise us. Just when we think that we have seen it all, we get a new idea and we think, wow, what a genius idea that was. But the thing is that if you don't know how to code, and most people don't, then computing remains a read-only experience for all these creative people. They've got all these ideas for apps they want to make, but they can't do anything with it, because at the moment, the challenge is that you're faced with two really bad solutions. Bad solution number one is you use a builder like this, and I'm sure they've done a great job, but you're limited because of the imperative programming, because of the cloud-based storage, because of all the rest and the layers of abstraction along the way. You just can't make everything this sort of way. And bad solution number two is the expensive and difficult path of having to go out and recruit people into your team, try and persuade them that your idea is good, try and find the programmers, and then to try and find the money to pay for it all. So I think we've missed the trick, and because of this, most ideas really don't go anywhere. I think only if we start rethinking the fundamental lower layers, the operating system, and particularly how we think about data, are we actually going to be able to produce a fundamentally new and different experience. And if we can do that, then we can slide in privacy and decentralization by the back door. And that's, I think, how we get to mass adoption. Thank you very much.